Hello everybody, welcome to the SAP 2000 course. As we know, SAP is a very important software to civil engineers. When we use SAP, we can easily design many types of structures. Let's go to our outline to show what we will learn in this course. Our outline consists of 6 parts. The first six steps are in part 1, and we have part 2, part 3, part 4, part 5, and part 6. And details, first of all, we will begin with an introduction to the structure design. These steps, we will learn in these steps how we can calculate the dimensions, the pre-dimensions of all elements using and design and structural design of a building, like beams, slabs, columns, and foundation. Then we will, in step 2, we will begin with the description of the project worked on. And the part 1, we will design a structural building consist of 15 stories with 1 basement. So we will describe and step 2 this building. And step 3, determination of dimension of structural elements. Then we will go through the SAP. We will begin with a introduction to SAP, define SAP 2000, how we can create a new project in SAP. 5, we will begin with modeling our building project with SAP 2000. And 6, we will begin the step of analysis and design of the building, of the structural element of the building, beams like beams, slabs, columns, and foundation. 7, we will begin to part 2 of this course. We will, in this part, we will define and design all types of stairs. In part 3, we will begin to define and design all types of water tanks. In part 4, we will go to advanced 2D work and SAP. Part 5, we will begin to design reinforcing concrete parking ramp and SAP 2000. Finally, we will, in part 6, we will design a dome and SAP 2000. And slide 3, we will show the description of the project, residential. And slide 3, we will begin and the description of the project in part 1. Our project consists of 15 stories building, residential building with 1 basement located in Lebanon. These are the material properties, the bearing capacity, height of the basement, height of the typical stories, earthquake system using in this project, the assumption of the thickness of shear wall and columns. We will show in this course, we will show in story 1 waffle slab type 1, how we can, what are the loads must assign to the slab and software. We will define the loads and how we can determine the thickness of the beams and thickness of the slab and this story. We will show this in the next lecture. We must notice that in SAP we can't define automatically as ETABS, waffle slab, or one-way ribbed slab. So we will learn a method how we can define waffle slab and ribbed slab and SAP 2000. We will show this method in the next lecture. In story 2, we have waffle slab type 2. We will show also the difference between waffle slab type 1 and type 2. Now in story 3, we have one-way ribbed slab. We will define one-way ribbed slab and how we can determine the thickness of beams and slab of this story. In story 4, we have flat slab. And finally, from story 5 to 15, we have solid slab. We will also link and define retaining wall. Now we will go to the stairs, part 2 of our course. We have 3 types of stairs: spiral stairs, cantilever stairs, 2-flight support stairs. We will begin with the spiral stairs. We will learn how we can define and modeling this and design this type of stair in SAP 2000. Now we have cantilever stair. As we show, this stair is supported on one side way. The cantilever stair, this type of stair didn't have a support on this side. Now we have 2-flight stair, the normal type of stair supported on the 2 side. we will learn also how we can define, modeling and design this type of stair. Also we will learn how we can determine the run and the rise of the stair and define these two parameters. Finally, in this project we will assume that the thickness of stair equal 18 centimeter, and we will put a dead load equal to 3 kN per meter square with a live load equal to 4 kN per meter square. So the live load is taken from the ASCE code, and we will check the thickness of the stair after the step of analysis and design. We will show the capacity if this thickness is below or above the required section. Now we will go to the part 3 of our course. We will learn on this part how to define, design and modeling the two type of ground define, design and modeling underground water tank and upper ground water tank. We will show many information and method of modeling and design of water tanks and SAP 2000 and this part. Now we will go to the part 4. We will learn in this part how define, determine and design a parking ramp and SAP 2000. How we can design and modeling this ramp and SAP 2000. Now finally we will go to design and define DOM and SAP 2000. Now also we will define earthquake loads and SAP 2000, how we can define using UBC 97 code or ASCE code. These are the slide consist of how we can check and define the earthquake loads and SAP or ETAPS. We can use this slide and SAP or ETAPS. Okay. This slide defines the loads and beam. We will show how we can put distributed load on beams and SAP 2000. Now, at this slide we will show the stiffness modifier for each structural element. Now, in slide 44, we will show how we can define a wind load and SAP 2000. Also, check story displacement and check story drift and SAP 2000. Thank you for listening. We will continue in the next lectures.